Hi, my name is Campbell McKenzie, and we are going to be going over some R code and explaining what each of these lines of R code does. And yeah. So the first line of R code we have is install packages r.plot, and basically it just downloads the package and it's for plotting decision trees. So let's run that, and it's going to download our packages to get ready for the decision trees to get ready to plot. Okay, so those are downloaded. So now we are going to install and download the carrot packages, and basically the carrot packages are used for modeling the confusion matrix and basically yeah. So let's run this and let's watch that happen. Okay. All right. So now that we have all the packages all downloaded and ready to go, we are on the fourth line and we are going to run a library read Excel. And basically this just imports the Excel files to this to Posit Cloud. So let's run that. Okay. And the library R part basically it builds decision tree models. It gets everything set up for building a decision tree model. So let's run that. The library R part dot plot. That is for, let's see, is for basically like visualizing the trees. Just giving you I guess it kind of plots out whatever tree is being ran or is being the code that is being ran, and it will pop up on the plots. So yeah, that's what happens when you run the library, and it just gets everything. The library rpart.plot gets everything ready for that. So let's run that. Okay, the library caret. That is basically it's basically a model for evaluation of the confusion matrix. So it gets that all set up and ready to go. So um, yeah, so let's run that and we'll get that all ready. So when I run that, it actually loads required packages for ggplot2 and also lattice. So it does that and gets everything ready for that and for the confusion matrix. Okay, so last one for library. Last one is library E. Sorry, this is something. Okay, library E 1071. Basically that it is. Thinking off the top of my head. Sorry. Let me get back to you guys real quick and let me pause this video just for 1 second. I know how to. No, 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 no. So the E1071, basically, it is the dependency of that caret that primarily uses for matrix. So it just basically it goes hand in hand with the caret and gets everything ready to go to run that matrix and gets the yeah, just basically just runs the matrix, gets everything ready for that, and yeah. So now that we run that, we are in the body data read Excel, body measurements. basically what that is sorry. So basically, when you run this code right here, body data, it imports data, the body measurements data into a data frame, which is the body underscore data. So that's what happens when you do that. So let's run that, and it does that. It comes down to the console window. So now we're at the LM model. So basically, this is for a linear regression model, the LM, and basically, okay. So basically, the LM model records a or fits a least regression. Basically, what that is it fits a least squares regression predicting body fat from the atom weight and height. So yeah, that's what that line of code does right there. So we'll run that and it will pop up in our environment window, body fat or LM data and body fat data. And here's all of our data right here. Um, so all the data for the body fat, abdomen, weight, height, and yeah. So once we run that, now we will do the summary. What's it called? Summary LM model. So for the summary LM model, basically it gives us outputs of coefficient estimates, like intercepts plus slopes. It also does R squared and how much variance is explained. And it also for the outputs for the summary, it does p values for each predictor. And basically, once we run this code, if I can get to it here, it will give us all the coefficients, residuals, min, 1Q, median, 3Q, maximize min, stuff like that. And it will give us the significant codes and the residual standard error, which is 4.446. And like I said, the p-value all comes down here into the console window and gives us all of our data that we need. So yeah, that's what happens when we run the summary of that model. So okay, so when we run the body underscore data slim LM underscore pred predict LM model line 12 basically code of line 12. Basically what happens is it generates the fitted values for let's see, the fitted values for the LM underscore pred, and it does it for each row. What else it does is it computes the RMSE of those predictions on a sample average, and basically it does a sample average of prediction error in the same units as body fat. So let's run that line of code and we'll do that. Let's see here. And it will come up here into the environment window. Let me or something happened in the environment window. Let's run that again. It was something. Okay, let's just do that one more time. Okay. Okay, so we did that and I explained to you what it does. So now, okay. So yeah, basically what I all I explained for that is okay, like I said, um basically what I explained is for these two lines of code, that's what I was explaining. And so I run this line of code and it gives us a lm underscore rmse of this number right here value, and it goes down to the console window. And now once we run this, it will come down to the console window as one, and it will give us value of 4.41099 So I guess it rounded to, let's see here, the nearest like something, but yeah, it rounded it up, and yeah. So now let's see with the tree model or line 15 line of R code. So let's get into that. Okay, so for line 15 tree model, it basically builds a regression line for the method ANOVA for the same three predictors. And it also plots showing splits of obsession, sorry, abdomen, my bad. And for 80, and it goes left forward and nodes the mean. So that kind of sounds a little bit technical, but once I run it, it'll show what I mean. So uh so it gives us a tree model, and once we click that, it gives us all the stuff that I don't know, it gives us all the stuff that all these points right here, like frame, where, cal, terms, method, and basically, yeah, it just gives us all this data type value, and yeah. So let's and it puts it up here into the R script window. Let's see here. So let's go back to the unit title. So we ran that. Uh, so and then it gives us all that, and it gives us a tree model right here, and it puts it up here. And let's see now about the body data tree, or sorry, R plot tree model. Let's run this and see what happens. And it comes down to here to the console window, and it gives us a image, a visual in the plots. So let's explain what these plots, or what this plot is showing us. So basically, this plot shows us the leaves, the nodes that each abdomen or each body part predicts, and gives us a number. And yeah, I got abdomen right here, and height, and basically it comes down with these nodes: one, two, three, four, five, six, 8 nodes. Let me make sure. Yep, 8 nodes, and yeah, it gives us that. So yeah, that's what happens when you run line 16 in R code, and it gets us a visual model. So now when we run the line 17 code body data tree pred underscore pred, so basically what happens is that it generates the tree-based predictions and computes their RMSE. And basically it does that. And it also compares R the LM, basically it predicts the LM underscore RMSE, comparing it to the tree RMSE. And basically what that does is it it sees which model fits the data the closest. So basically that's what it does. So let's run that line of code and see what happens. And it just comes down here, and but I guess it just gets everything ready for that particular thing I was talking about. So now we're on line 18, and basically, let's see. Okay, okay, so basically for tree, you know, we run all that. Let's get that going. Let's see here. So run this, and it will give us the tree RMSE of that. And what I was talking about in line 17 and 18, these are both the stuff I was talking about before about line 18. Basically, you got to run these three lines right here to get what I was talking about. So yeah, we did that, and it gives us the tree RMSE of this right here. So let's get the actual one where it's all cleaned up and rounded to the actual number. And it is 4.2611 uh 2. So that is our RMS value for the tree, or yeah, tree model that um the tree RMS value. So yeah. So now let's get into line 20 of our code. So now we're getting into line 20, like I said, and we're getting into loan data and basically read Excel loan applications. So basically what this does is that it imports let's see, it imports your loan file data, and it converts it into two columns, and these two columns are loan re loan I'm sorry loan data, uh, and it has a Y or an N, yes or no, and also brings down the credit, which is let's see here, in line 22, all these lines right here. When you run these lines of code, it has a credit history, and it either is 0 or 1. So that explains what happens when you run these line of code. So let's do that. Okay. Loan applications. I guess this are variables and observations. Okay. So let's run the line 21, see what happens. Okay. Can travels down, it goes into the console window here. Okay. And that too. And yeah. Um let's see what happens when we do that. Okay. All right. Okay. Goes down to there. All right. So yeah, that's basically what happens when you run those lines of code. And let's get into line 25, and let me explain it to you. So now that we're at the loan, or we did the loan, let's run this code real quick. Now let's get into line 25 and 26, and basically, let me explain to you what's going to happen. Basically, what happens when we run these two lines is that it fits a logistic regression, predicting the probability of a loan approval. And for line 26 is it just gives us the outputs of the model coefficients on the long long odds scale, and basically gives us a significant test and a overall overall fit of the stat or statistics. So let's do that, and let's see what happens. Yep. Okay. So gives us our puts up on the environment window, loan data and log model. Okay. So I'm sorry. I'm just checking this out. you know. Let's go back to that. So let's get the summary and see what happens. See if what I'm saying makes sense. Okay, so yep, it gives us puts us down into the console window, and it gives us all this code, basically just to estimate error, value, coefficients, intercept, credit history, application. So yeah, that's basically what I explained here is right here down here. Yeah. So um, now after I just explained that, let's get into the loan data or line 27. Okay. So now that we did the summary, log underscore model or line 26, now we're getting into the loan data pred underscore predict or line 27. And we are going to be talking about line 27, 28, and 29. So basically, so for 27, line 27, it computes each applicant predicts of Y. Um, sorry, let's see. Sorry, not Y, response. And line 28, it that's basically no, it does predict the Y. I'm sorry. Sorry. It just that's the response. But for line 28, it applies to the OJ threshold and it has two let's see, two into a two that are into a class prediction of Y or N, and it gives us a prediction of zero point 0.5 of that happening, or 50%. So yeah, for line 29, basically it's a confusion matrix, and basically it displays the confusion matrix when you run that line of code. And it has true positive, it shows the true positives, negatives versus the false positives and negatives. And basically, it once you run the confusion matrix, it just gives you your overall accuracy and sensitivity, specificity, specific. I can't. I'm sorry. Basically, this specific number, I guess when it's like all when it's computed, it gives us our number that's rounded up. So yeah, that's basically what it does once we run that confusion matrix for line 29. So let's run these three lines of code and show what happens. Okay, goes down there to the console window. Okay, gives us that, yes or no. And once we run the confusion matrix, it gives us all of our stuff the overall accuracy, gives us our p-value, sensitivity, specific. I don't know why I can't say this. Specific. Sorry, I'm just not even gonna say it because I'm just gonna embarrass myself. But anyways, you know what I'm saying. For this, and yeah, that is what happens when we run that line of code. And let's see if there's anything happens in the environment. Oh, okay. So yeah, let's get into these last let's see, two, three, four lines and call this a video. So now we are at the tree model or line 30 of line of code. So basically what line 30 does is it builds a classification tree and rather than a regression tree, and it is for loan approval. So yeah. Um, so let's run that. Okay, goes down here and does that. Okay, now we're at line 31, and basically it just plots is going to plot the decision tree or decision rules, sorry. So let's do that. Plots this, I can plots that right there. Our credit history and no and why, no, yes, percentages, stuff like that. Um, so for line 32, line 32 and 33, it basically just predicts in cases class, and again, it reports the accuracy matrix of the confusion model or confusion matrix. Sorry. So let's do that. Let's run these lines of code. And yes, it does the same thing as same thing as or just gives us the confusion matrix and gives us our accuracy of 0.8456 and our p value and positive class n no or an n, and it gives us our accuracy specificity. I'm sorry. Anyways, but yeah. So you see what I basically explained to you what happened when I ran this line of code, and it gives us this. And yeah, that is all the code that I have here. I successfully ran tree model, regression model, and logistics model for you today. And yeah, and basically this is what we get here. So let me pause this video real quick.